Hello everybody, welcome back to this training on natural language processing. This is the third of the series of videos we have for this training, and in this video we will talk about how we can do some subsequent representations of text data, taking the document term matrix as the basic foundation. And then obviously it leads us to some of the applications of exploratory analysis on the text data. If I do a quick recap of what we discussed in the first two videos, so we looked at how text data can be represented in a structured form, in the form of a matrix, so that it can enable us to analyze text data in a similar way like we analyze numerical or categorical data. And we called that matrix as the document term matrix, and we also looked at some features of that matrix, like the rows of the document term matrix are basically the number of data observations that I have in the data, and the columns are number of unique words or number of unique tokens that I have in the data. And we have also looked at two unique features of the DTM. One being the fact that it's a very high dimensional matrix. Even after removing the stop words or doing the basic cleansing of the text data, the dimension continues to be pretty large, primarily driven by the high number of columns. And it's also a very sparse matrix in the sense that a lot of elements in the matrix are zero. So these are the observations we carry over from the first session. And of course, we did some hands-on, some mild hands-on exercise in R, wherein we imported a data, and that it was a data on product reviews from Amazon, and it was data on and the data was labeled as positive reviews and negative reviews. And then we constructed the document term matrix from that data and inspected the structure of the document term matrix, the columns, the rows, the amount of sparsity, rank of the matrix, etc., etc. Okay, so with that as foundation, we can now march ahead. So once the DTM has been created for us, it actually gives us the foundation for doing exploratory data analysis. And no wonder, guys, when we do handle numeric data or categorical data, before we go into any kind of supervised learning or unsupervised learning, the first step is obviously to do some data wrangling work, some exploratory data analysis, in order to find out some basic facts about the data. So no exception for the case of text data as well. Now that we have represented the text data in the form of a DTM, we will do some exploratory analysis on the text data. Now, in order to do the exploratory analysis on the text data, we have to look for some kind of a representation model of the text, which will flow from the concept of document term matrix itself. Now, one of the representations of text data, which is document term matrix, which comes from the document term matrix, is called the bag of words model, or the bag of words representation of text data. In many literature, you will find the word to be abbreviated as BOW. So BOW, it stands for the bag of words model. So the bag of words model have different forms, different variants, but fundamentally it is basically derived from the DTM itself. So this representation of different observations in rows and different unique words in columns is called the bag of words model. Now, what we have within that matrix as elements will determine different shape and form of the bag of words model. And once we have developed the bag of words model, we can do many kinds of exploratory analysis, like the tokens per document analysis. We can do different visualizations and find out the structure of the text data that we have, or what kind of context lies hidden in it. So let's formalize the concept of a bag of words model and look at different variants of that. Okay, I realize that my face is blocking some of the board work out here, so I better go off the screen. Let me switch off the camera. Okay, I hope I did so. So this is the formalization of the bag of words model, right? So what what we look at in terms of the formalization is that obviously the bag of words model is is represented using the document term matrix, but then there will be different variants of the bag of words model. So we have a term frequency model, and then we have a normalized term frequency model, and finally we have the TF-IDF model. Now how these models differ is basically depending on how we are defining the different elements of the document term matrix. So of which the term frequency model is obviously the simplest, but not the most popular. The most popular is the TF-IDF model. But since we are introducing this concept for the sake of illustration, what we will do is we'll look at the term frequency model for the purpose of illustration. Obviously, later in the course, in one of the videos, we will discuss extensively about what the TF-IDF model is, because that is the most popular representation for the bag of words model, and that is what we'll end up using in most of the practical use cases. Okay, apart from the bag of words model, there are other ways of representing text data as well. So something which is called word vectorization, and then word vectorization can also be done in different ways. There are different algorithms to represent words as vectors, and they being one of them being the global vector model, which is often abbreviated as GLOB, and then we have the continuous bag of words model, which is abbreviated as COBOW, or sometimes it is called CBOW as well. Okay, but these are computationally more difficult, more expensive to compute rather than the bag of words model. And then we have topic model using latent Dirichlet allocation, and we also have latent semantic analysis. So these are applications, these are techniques, which have much wider applications than just representing words as features. But then using these techniques as well, we can get some mathematical representation of text data as well. So we will look at how topic model and latent semantic analysis helps us represent text data again in one of the later videos. For the time being, we'll stick to the most simplest of the text representation model, which is bag of words, and within that we will look at the term frequency model, which is again a very simple thing to look at. Okay, so how does one construct the bag of words model using the term frequency? So that was the bag of words model. So once we have represented the text data using the DTM and the bag of words model, we can do some exploratory analysis. For the time being, ignore the R script out here. When we do the hands-on in one of the next videos, we will definitely run this code and explain what it is doing. But look at the visualization out here. So what we are looking at here is token count per document, or in other words, the example that we are looking at, Amazon product reviews, we are looking at typically uh, how many words or how many tokens are present in every review. And you see the mode here is around 3 or 4. So most of the reviews have 3, 4, or 5 words in them. That is where the density of the histogram is maximum. But apparently that would sound quite counterintuitive, right? I mean, how can somebody write a product review in just 3, 4, or 5 words? So two things here. One is, these are not very lengthy reviews that we are looking at. These are short reviews, maybe 2, 3 lines. Somebody just making a comment about one or two particular feature of the product. But even if it is a 2-line review, how come we are saying that most of the reviews have 3, 4, or 5 words and not more than that? Because that is where the density of the histogram is located. I'm sure most of you would have guessed the answer by now, because what we have done is we have stripped off the stop words from the reviews. We have done the other basic cleansing which we discussed in the previous videos, which has kind of trimmed down the number of words in each of the reviews to a much lower number than what it was actually. And so the sentences or the reviews have lost the grammar, has lost the aesthetics, but they still retain the context. So this is another very popular visualization of text data. So this is something which is called word cloud. Once again, when we do the hands-on, we will see how to create a word cloud. But it's a no-brainer. I mean, the size of the word is proportional to the frequency with which the word is present in the entire data. So more frequent a word is, the bigger the font, the bigger the size, so on and so forth. So very simple representation, but very powerful and very useful. So in this case, since this is in product review data, you see, you immediately understand that most of the reviews are about phone. And then people are talking about headset, they're talking about battery, they're talking about the product in general, they're talking about the quality of the products, so on and so forth. Okay, this is something which is called comparison word cloud, and pardon me for the resolution out here. So in this case, the data that we are handling is actually a labeled data. So we don't just have the reviews, but we also have for each review whether or not it is a positive review or a negative review. So which means that we can actually look at the most prominent words across the two classes, the positive class and the negative class, by splitting the word cloud. So this is what it is doing, and it not just helps us understand what are the most frequent words in the data, but it also tells us that within the positive reviews what are the most frequent words, and within the negative reviews what are the most frequent words. So once again, very simple, but incredibly powerful, and can give you a lot of insights about the data. So we are still doing exploratory analysis, by the way. And this is something which is called a keenness plot. So not going behind the statistics of it, but if we just look at the visualization, once again what it says is, so there is something called a target and the reference. So in this case we have called the positive reviews as the target and the negative reviews as the reference. And it says that again, uh, intuition wise it's similar to the comparison word cloud. So it says that for the positive reviews, what are the most predictive words. I'm using the term predictive here because ultimately when we do supervised learning using text data, these insights will come out to be very handy. So it's actually telling us that which are the words which are biggest determining factors of a positive review versus which are the words which turn out to be the biggest determining factor of a review being negative. So again, very simple visualization, but incredible amount of insight which you can carry forward as you move ahead with analyzing the text data. And finally, this is another piece of code that will generate the keenness plot, but we'll obviously run it when we do the hands-on session. So that brings us to the end of uh, the bag of words representation discussion. So the bag of words representation, what it does is it helps us do a lot of exploratory analysis, which are fairly simple, but then they can give us a lot of insights about the data right at the onset. And we looked at the most simplest form of bag of words representation, which is text using the text frequency, and discuss some of the pros and cons of the bag of words representation. So in the next video, we'll continue with the exploratory analysis. We'll look at some of the more intricate factors, like, instead of looking at words in isolation, how can we look at different combination of words? Because when we talk about text data, when we talk about language, it's not just about words in isolation, right? There are phrases or combination of words which often carry special meaning as well. So that's what we will discuss in the next video. That's all for this video. Thank you for watching it, and hope you're enjoying the training. See you in the next video. Bye.